Hey guys, I've recently been experimenting on the FPS movement in Unity. In this video, I'll explain the code as well as how to implement it using the new input system. For building an FPS movement, we need the following things: the script to control the camera and the player orientation. Then we need to make sure the camera is actually following the player. And then using the new input system, we can build a input script with which we can actually, dictate which actions will take place when. Okay. Before starting off, we should know the difference between the old and the new input system. So why do we use the new input system here? The new input system has a lot of advantages, like it can provide more customized and flexible input handling, offers support for a wide range of devices like gamepads, joysticks, and even custom input devices. It's also best suited for cross-platform development and has an action-based input where we can customize which action is triggered by which input from the device. And if the input system seems hard for you to learn, you can always use both simultaneously. Hit up a new Unity project. Here I have a capsule, which is the player, and a camera which will follow the player. Okay, so the first thing you need to do is parent the camera to the player like so, and you'll see that there is no change in the game view here, right? That's because you need to reset the transform here of the camera. So go ahead and click on the three dots in the inspector window and click on reset. Okay, great. Now you can see the scene view, okay, from the eyes of the player. You can always shift the camera. Okay, let me go ahead and change the orientation here. As you can see, it's showing like this. Okay, so you need to do it, yeah, in first person movement. You will see from the point of view of the player. Okay, so keep that in mind, and the field of vision is this right here. Let me quickly change the material. Okay, so as you can see, I've changed the material so that you can see the camera field of view. Okay, and now we're gonna go ahead and import the new input system. So to do that, you need to go to Window, then Package Manager, and the new input system will be available in the Unity registry. Okay, and let it load. Okay, so here, let's see, you need to look for the new input system. So just search in new input system and you'll see the input system right here, and click on install. Okay, now it will take some time to install. I'll see you then. If you have installed the package, it will ask you to, do you want to enable the backends? So you need to click on yes. Okay, we'll only be using the new input system here, so let it re-import right here. Okay, great. Now let's press save. Okay, once it has finished importing it, okay, now you can go ahead and see the import the input script. So go ahead and right click on the folder where you want to create the input system, then click on create, and then go down, all the way down below the terrain layer. You'll see an option called input action. I don't think you were able to see it, okay, but it's actually there. Let me try it to show. Okay, it's not showing up on the capture, but it will be below terrain layer. Okay, so below search, then brush, then terrain layer, you'll see the input action. So when you click on that, go ahead and rename the input action to player input. Alright, with that done, let us go ahead and open up the action, a player input. Okay, so you'll see that there is nothing here because we need to add a new action map. Okay, so let's go ahead and input or create a new action map. This action map will be the on foot. That means it will control the actions of when the player is on the ground. Now with this action map, we can create multiple actions. Okay, so what do we do when we are on the ground for a player? Well, we definitely need to move around with the WASD. Okay, so let's go ahead and rename this action to movement. Okay, great. Now if you see here that the movement has something called binding, right? Now what is a binding? Every action has multiple bindings. That means the binding is responsible for what triggers this action. Okay, so what will trigger the movement action? Okay, so suppose I press A on the keyboard, then it will trigger some movement. Like suppose you are making the player move to the left, or you can have a jump action. When you press space, the player jumps, something like that. Okay, but for this case we are using a WASD, right? So you gotta change the movement type, action type, to something else like value, and the control type to a vector2. Okay, and then you need to click on the add binding, and you'll see add up slash down slash left slash right composite. Okay, now with this you have the options of triggering the WASD binding. So for the up arrow key, we can have where you need to set the path to W keyboard. Then down we need the S, right? Just select that, right? Then for left we have A on the keyboard, and then for the right we have the D. Right, now you can even have add actions or bindings for something like a gamepad as well. Okay, and you can change the binding here. You can see the option right here: gamepad, joystick, and keyboard, and multiple stuff. Okay, so you can play around with that, but for this tutorial we are showing for only for the keyboard input as well as the mouse input. Okay, now let's add the action for jump. So for adding a new action, click on the plus icon next to actions and rename it to jump. This time it will have only one trigger event, which is button. Unlike in movement, we needed a vector2 because the player needed the values for X and Z values, right? But this time we only need one input, which is space. So go ahead and add the binding space. Just type in the keyboard space and this will show up. Alright, and like so we have added the space binding to the jump action. Now that we have everything set up, we can actually convert this player input action into a C# class. How do we do that? Well, if you have the thing open, first before doing anything, click on save asset, and then over here in the inspector window you'll see generate C# class. You need to check mark this option right here and click on apply. When you do so, you will see a C# class with the player input. Okay, and like so we can use this C# class to control and manipulate which actions the player must take when the binding or the buttons are pressed. Okay, with this we can actually read the values. Okay, so that you'll see when we actually script the code for the player movement. Okay, so for scripting the WASD and the jump action, let's create an input manager script. Now since we are using the new input system, we have to include it in the script. So, include it by using the using keyword and unity engine.input system. You remember the player class we created? Using this class, we create the object for that class, and we also reference the onFoot actions that we have in the input action map. Now with the awake function, we initialize both the input and the onPut variables. Then create two more functions, onEnable and onDisable, which disables and enables the onFoot action. Next up, create the player movement script. In this script, create the character controller component reference, and then we have two variables, the player velocity and the speed. Then on the start function, initialize or get component the character controller of the player object. That means your player has to have the character controller component. Next, define a user-defined function called processMove, which takes in vector2 input. Now this input right here is the input that we'll read from the action map player input that we had created before. So for defining the move direction, we set it to vector3 0. That means it's set to 0, 0, 0. Then we read the x input from the input.x and the move direct z to move input.y. Now here's the thing, why did we take z instead of y? Well, that's because our player is moving along the x and z axis horizontally on the plane. And if it were given the y, that means it would be moving up along the y-axis and along the z-axis, which wouldn't make sense in this tree space. Now use the controller.move to move the transform or the player transform towards the move direct direction. This is the advantage of using the character controller component on the player. Using this, we can literally just tell the player to move towards this direction. But now that you must have noticed that we have set the process move as public. That means it can be accessed outside this class if it has a reference to this class. So where are we going to use it? Well, we are going to be using it into the input manager script. So head over to the input manager script and define the player movement reference. Then in the awake function, go ahead and get component the player movement script. Okay. Now in the fixed update method, we are calling the process move. And what are we passing? The input vector. So the input vector here is the onFoot dot movement dot read value vector2. So let me explain. So here in the action map, we have the onFoot, right? And we have the movement, right? Movement action. And this movement action has 4 bindings. WASD. Now it's gonna read the vector2 value of the keyboard input from one of these keys that we press into the keyboard. So that red value is passed as the input parameter to the process move function. Now if we run the game, we'll see that the WASD keys are working well. However, there is one more thing missing, and that's the jump action. When the player is jumping, it experiences the force of gravity. So we need to add that as well. So how do we achieve this? Create two variables. The bull is grounded to check if the player is on the ground. Then create another variable called gravity, which is a float value of minus 9.8 newtons. Okay. Now in order to control the player velocity, we're going to be using the player velocity variables y value and it's gonna be added to the gravity into time dot delta time so that it sets at updates at the frame rate, you know and then we are gonna be checking if the player is grounded, is true, as well as if the player.y value is less than 0. That means the value that it got updated to is below the plane. If it's below the plane, then we want to set the player velocity dot y, that means the player's y position, to -2. So that's basically a very rigid way of fixing the position of the player, or telling the player not to go below -2f. Then we use the controller.move function, and this time we're going to be moving, or rather using, the player velocity into time.delta time. With that, we can control the player's y position. Jumping has a limit. If you do not set the jump height to something, then the player might, go all the way up to the heaven and may not return to the ground. So to avoid such a scenario, we are gonna be setting the jump height limit, which is 3f. Then create a jump function, and we are going to be checking if the player is grounded. That means the action, or the space action, whenever the player or the user presses space, only then the player should jump. It shouldn't jump when the player is off the ground. Okay, I hope that makes sense. And now what we are doing here is increasing the player velocity to a jump height. So it's gonna move till the jump height and not more than that. Now let's go back to the input manager script and call the function, the jump function. So here we are going to be using a pointer here. Okay, why are we using a pointer? Because we are going to be checking if the action is performed. So here on foot.jump.performed here indicates that whenever this action, or the binding associated with this action, is pressed, then it's gonna call the function jump. Okay, let's try running it in Unity. Oh, it seems the player is going up and up and not falling down. Okay, so it would seem in the player movement script, I forgot to multiply the direction in speed into time.delta time. The time.delta time is pretty important because it's gonna make the player move in a particular frame rate, or a fixed frame rate. If it doesn't, then it will go haywire. Alright, so do not forget about time.delta time, as well as multiplying with the speed. Okay, the speed indicates the speed at which the player is moving. Okay, so do you remember the is grounded bool variable that we had made in the player movement? Well, we actually forgot to update that. So in the update method, set the is grounded to equal to controller.isGrounded. Now here's where the character controller component is very useful in these type of games. So character control component has a way of checking if the player is colliding with, or is currently colliding with, any mesh that has the box collider or any type of collider. Okay, so by default the mesh or the plane it's on is identified as a ground for the from the player's perspective. So here, this way of updating the is grounded bool variable actually works. All right. Now with that, if you hit the play button, the player successfully moves with the WASD keys and successfully jumps when the spacebar is pressed. Well, it's all great and all, but we haven't yet added the camera perspective, which is the main part of any FPS games. So what we are gonna do is gonna define a new action called look, and it will be of action type value and the control type vector2, just like we had in movement. But unlike movement, we only have one binding here. Why? Because for the mouse, we are reading the cursor's position. That means we only have one binding here, unlike we are not actually pressing multiple keys here, because we are recording the position of the cursor of the mouse. So wherever the cursor moves, that's the direction where the player will be facing. Okay. Now let's create the player look script. So in this script, we're gonna be defining the camera the camera reference and then the X rotation for indicating how much it will rotate on the X axis. Okay, now this will be a bit complicated to explain. Okay, but for now, let's define the sensitivity of the mouse, which is xsen and ysen to 30f, and then create the process look method of vector2 input, which takes vector2 input, and it will be a public type because we are going to be calling and matching through the input manager script. Okay, and over here, for the mouse input, set the mouse x to equal to input.x and mouse y to input.y. Now set the x rotation to the mouse x into time.delta time into y sensitivity. Now I'll explain why I wrote y sen instead of x sen soon. Okay, and then we have the line x rotation is clamped through the math f with the help of mathf between the 80 minus 80 and 80 degrees. Okay, now it's time to understand how all of this works. Okay, so whenever we are rotating the camera, okay, we're rotating the axis of the camera. Okay, that's why we are using the y sensitivity instead of x sensitivity. Now if you see here, suppose I am looking to the left or to the right. So which axis do you think we have to rotate? The x-axis or the y-axis? Well, the definite correct answer is the y-axis, because if you think about it, if we rotate it with through the y-axis, we are rotating the whole object around that plane, and with that the player is able to look to the left and to the right. Now for looking up and down, over in this line that we have x rotation, we are using clamping it between minus 80 and 80. Okay, so through this diagram, if you see, we are rotating the x-axis of the camera, and this rotation is clamped between minus 80 and 80 degrees. That means it can't look up and down beyond that much degrees. Okay, hope this explanation makes sense. Okay, it might be difficult to grasp at first, but through some visualization, I hope it's a little bit easier to understand how the orientation is controlled in such type of games. Okay, now the camera is local to the player, so we are gonna be rotating through the local axis. Okay, and using the Quaternion.Euler method, we're rotating on the x rotation, 0, 0. Okay, so this way we can rotate the x-axis of the camera. That means it can look up and down. Then as for rotating along the next line, transform.rotate we're rotating the y-axis this time, so we are going to be using vector3.up. What is the value of vector3.up? It's 0 comma 1 comma 0. That means it's going to rotate the y-axis. Okay, it's going to rotate along the y-axis. So the player is able to move to the left, or actually look to the left and to the right. Then with the mouse X, because we are reading the X location of the cursor, okay, and then we are multiplying it with time dot delta time to so that it rotates at a particular frame rate, okay, at a fixed frame rate. All right, and here we are using the X sensitivity. All right, with that we have finished this function, the process look. Now it's time to call this method from the input manager script. Over in the input manager script, define the player look reference, okay, reference to that script. And the since the player look script is attached to the player itself, we can just directly get components it in the awake method. All right. Now the orientation of the camera is called as the late update. That means it's gonna update the orientation of when the player is looking to the left, right, up and down, a little late compared to the update and the fixed update. Okay. And over here is where we are gonna call the look.process.look. That means we are gonna call the process look function in the player look script. Okay, but this time we're reading the or passing in the cursor's position. Okay, so we are sending in the input value of the vector2 value position, vector2 position of the cursor. Okay, now when we do that and hit play, we are able to look around our scene. All right, so yeah, that's basically how you make an FPS controller for actually using the new input system, right?